My name is Will Carruth. I'm a research civil engineer in the Airfields and Pavements branch of the Geotechnical and Structures Laboratory. Today we're working on a project that's part of the expedient and expeditionary airfield damage repair. We're trying to come up with ways of repairing airfields that have been damaged by bombs or some other weaponry to be able to return them to service so our aircraft, our fighters and cargo aircraft can land once again. But we're trying to do that in a manner that reduces logistics. So we're trying to maximize use of existing local materials, bringing with us as little as possible in a low logistical footprint, but still be able to get a certain number of aircraft passes and make sure that our aircraft are safe in terms of structural capacity of the repairs, making sure we don't have too much deflection in our repairs up or down that might cause damage to our aircraft. So we're trying to figure out what kind of binders or what equipment can we bring with us and maximize the use of those local materials throughout our repair process. The mat we're testing is an existing mat that we've done a lot of work on in the past. We know it works in terms of the repair process and its structural characteristics. The mat's pretty thin, so we can bring more mat than we could concrete or some other material that weighs a lot more and would take up a lot more volume in our aircraft. So our experimentation here is going well. We've conducted testing with the same fiberglass reinforced polymer mat or FRP mat under several different backfill materials. So that's what we're doing right now. One of the repairs is cement stabilized soil, which is a technique that's used quite a bit in the highway industry and in traditional construction, so we could bring the cement with us and stabilize whatever soil is local and available. The other repair we're testing right now utilizes debris from the actual crater blast, and we process it and break it up down into relatively smaller pieces, approximately an inch or less, and place that material in the excavation and fill in the voids with whatever local material we have available, and compact that and put the matting over it. So those are the two repairs we're conducting as we speak. This project aids the warfighter in providing a capability to conduct expedient airfield damage repairs in a deployed environment where they may not have a lot of equipment or advanced materials solutions to be able to conduct these repairs. So we're trying to provide a method that's easy, requires minimal equipment, but still performs well in terms of meeting the target number of expected fighter or cargo aircraft passes.